Good afternoon, everyone. Hello.
Yeah, good afternoon, sir.
Good afternoon. Sometime at the start of the session, you can turn on your videos that your uh, participation will be recorded, your face will be visible. Otherwise, we'll have no photographs to show.
So someone has requested on the WhatsApp group to share the.
Yes, again, I'm doing that. Yes, I have received.
In the meantime, if anyone has any feedback with respect to the pace, the content, please feel free to share, so that I can learn from that feedback and change my pace or the content for the next 2 hours.
I think we can start.
Okay, I'll start. While presenting, I'll keep my video off so that it uses less data bandwidth at your end. Now, okay, I'll just share my screen. Let me know once you are able to see my screen. Is my screen visible now?
Yes.
Okay, so we left at this just before the lunchtime, and we were discussing about filter and the cutoff frequencies of the filter. We had seen that while we did not have filter, the power of this noise signal was around minus 10 dBs. Now, after adding the filter, the power of the noise signal has come down drastically to minus 75, minus 80 odd dB. Yeah. I'll show you just one more thing, and then we jump to talking Tom. I'll increase the order of the filter. I had used a third order Butterworth filter, but now I'll use a ninth order Butterworth filter. And we would see that the power of this noise signal should further go down. So the power of the noise signal now is less than minus 200 dB. Minus 200 dB is lesser than the theoretical noise floor. So you can see that the signal has gone below the thermal noise floor, and hence ninth order Butterworth filter in this case is able to help us reduce the noise signal to a very large extent. Okay. Now, with that, I will jump on to another application which we had promised, that is the Talking Tom application. So people who had not installed DACMX and were not able to follow me during the last session, from now onwards, they will also be able to participate and make the program at their end. So don't worry if you don't have DACMX installed, that is not needed for the next session of Talking Tom, right? So all of you who have Labview installed can work along with me for this program. So before I get into talking Tom, I just want to deliver a small concept. Let's say if I have these points. Okay. Okay. Let's say I have these 10, 12 odd points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 13 points. These points represent what waveform? Sinusoidal waveform, right? Now let's say this sine wave, I plot these points in 1 second. That means let's say this point on the x-axis is not theta, but let's say it is time, and this is 1 second. Okay, this 13th point ends up at 1 second. Then what will be the frequency of this waveform?
One by 2 pi.
1 by 2 pi. That's in omega domain, but in the time domain, can I say it's 1 hertz?
1 hertz. Yes, sir.
Yeah. What if I plot these 13 points in 2 seconds? What happens? What will be the frequency of the waveform?
2
5
hertz.
hertz. 1 by 2.
1 by 2 hertz. Yeah. Because what I'm doing is I still have these 13 points and my waveform doesn't finish in 1 second, but now finishes in 2 seconds if I plot it in 2 seconds. What if I plot these 13 points in half a second? Let's say this point on the x-axis is 0.5 seconds. And what's the frequency of this waveform? 2 hertz, right? Great. So you understand the point that if I have a waveform and I change the rate at which it is plotted on a graph, I can play around with the frequency of the waveform. Is that statement correct? Let's say if I have these waveform points and I change the rate at which they are plotted on the curve, will I be able to change the frequency as we just saw?
Sir.
Yeah. So what do we do in Talking Tom is we first of all acquire your sound signal. Okay. We acquire your sound using sound card of your laptop, PC, computer, whatever you may have. Then we we play around with the timing of that signal. So let's say we acquired sound signal for 5 seconds. We play that complete waveform back in, let's say, 2.5 seconds. So what will happen is the frequency will double and it will sound like a Talking Tom. That is what a Talking Tom application does, right? So what are the building blocks of a Talking Tom application? First of all, we need to capture the sound signal, we need to change the frequency, and we need to play it back. Okay, now let's get back to Labview application. So together with me, go to the block diagram on a new VI, right click, go to Express, go to Input, and there is a block called Acquire Sound. Place that block onto the screen. It will show you the available microphone devices. I only have one microphone device, which has 2 channels. So I'll use both the channels. I can preview my waveform here. So while I'm speaking, it is picking up the voice signal and putting it onto the graph. I will slightly increase this duration to 5 seconds. The rate at which I will acquire, I will keep it to 22 kilohertz itself. I can do it lower also. Yesterday we discussed that human speech frequency is up to 3.4 kilohertz. So we can safely use 8 kilohertz also. Right now I'm using 22, but at a later point in time, we will reduce this to 8 kilohertz as well. Okay. And I can say, okay. Is it clear to everyone? Is everyone able to place this block onto the block diagram?
Yes, sir.
Now, what we will do is we'll go to the front panel, go to silver, place a graph to see.
Sir, what's the sample rate we have taken? 8 kilohertz. 8
Right
kilo
now
samples.
we have taken 22 kilo samples per second.
Okay.
Okay.
Okay, sir.
Yeah. So what we will do now is we will acquire this data and plot it onto a waveform graph. So on the front panel, we will place a waveform graph. Okay. And connect this to this. Okay. Now
We are connecting a waveform graph, not a chart.
yes, because what I'm doing right now here is I'm not having repeated signals. I am just acquiring sound for 5 seconds and then plot it just once on the graph. Yeah. Chart has a history. So in this application, I need not know about the history of the history of my waveform. Yeah. So there's a request on the chart window to repeat the first step. Definitely we shall repeat. So I will delete whatever I had created. I'll go to the block diagram, right click, go to express, input, and acquire sound. Okay. In this acquired sound, I will choose microphone, channels, duration to be 5, sampling rate default. I only have one microphone device, so I'm using that. I would say okay. Is my voice audible?
Sir.
Okay.
Yes.
Is the step clear now?
Sir, actually, it did not ask me the permission about that microphone, sir.
Permission about the microphone, sir? You have the microphone device connected?
Yes, sir, I have 2 microphones, but it did not prompt any dialog box.
When you place this acquire sound, it does not prompt any dialog box for you, sir?
Yes, sir.
Can you delete that and place again once?
Yes, sir. Just a minute, I will try.
Okay.
Yeah, now I got it, sir.
Okay, great. So once you have set the settings to duration 5 seconds, sample rate default as 22 kilohertz, and choose the correct microphone. I only have one, so I've chosen that. And you can then press OK. Once you have this placed, you can create a graph on the front panel and wire the graph to the signal being acquired from here. Okay. So what I'll do now is on the front panel on the graph, I will right click visible items and graph palette. I will make the graph palette visible so that I can zoom in into the waveform which will be acquired. Anyone, any question? Okay. Now I'll test this out. Let's say while I run this, I'll keep speaking something so that it's recorded on this graph. We'll say, hi, my name is Vinit. I'm conducting a Labview workshop. Yeah. So this is the waveform of the audio signals captured by my sound card. I can go into each of these and analyze.
So it shows only after 5 seconds, not like instantaneously. It is not showing, right?
That is because, Raghav, what we're doing is we have requested this block to record for 5 seconds and then give us data. If it was an actual real world case, while we would have met face to face, we would not have acquired this using your sound card. We would have acquired this using the MyDAC device, which has a microphone jack. That can give us a much better control on at what rate we can acquire data. After, let's say, 1,000 samples, we can keep streaming data back to host, right? Keep streaming data back to Labview. But the sound cards typically, I mean, it takes considerable amount of time to get back data from the sound card. So we don't do continuous acquisition from sound card right now. Even if we do, we will keep missing some data in between. So we are requesting sound card to record for 5 seconds and then just give us those 5-second data. Okay. In an ideal scenario, I would recommend to use a MyDAC or any industrial DAC system which has a microphone input to acquire these kind of signals. Yeah? But sorry for the lack of resources. We are in a different world in 2020 where we can't meet in person and do this kind of trials and exercises. So anyways, we have acquired data. Is everyone able to acquire your own voice signals?
Yes, sir.
Okay, great. So, sorry, sir?
Yes, my data is not acquired.
Your data is not acquired. Okay.
Please repeat this step.
Absolutely, sir. You have this acquire block placed.
Yes.
Just double click this acquire block. You can choose microphones. Does any microphone show up here?
Yes.
Okay. How many show up here, sir?
Two microphones is there.
Two microphones are there.
One is mic and one microphone.
One micro. Okay. Do one thing. Choose any one here right now. I don't know which one is a valid device in your case. Right?
Yes. Yes, sir.
Click on preview.
Okay. Click on
preview. Preview.
Oh, okay.
Hello. So
yes, sir.
I could see my signal being acquired.
Yes, sir. Now it is acquired.
Acquired, right? Okay.
Yes,
so
sir.
Keep the duration as 5 seconds.
Yes, sir.
Sample rate is 22 kilohertz and say okay. Okay.
Okay, sir. Now
you are able to. Hello. Okay. Rahul, sir, you got the data in the waveform. Then we can move ahead. Okay, I assume that as a yes. So once we have acquired the waveform, yes.
Sir, actually what I was saying, sir, we have not specified any like amplitude range. So it is automatically mapping our voice, the loudness of our voice according to the amplitude,
It is normalizing it in ±1.
Okay. Sir, because in the voice that is acquired on my end, it's ranging from -1 to +1. Like it's going 1 also, it's going -1 also. But in your case, I see it's from -0.3 to +0.3. So
yeah.
it will just normalizing there, and it will always take from -1 to +1 only.
Yes, in the current case, yes.
Okay. So we cannot change that. Like in my deck, it was there. There were two ranges, ±2 and ±10. So we cannot customize it over here.
Not on the sound card, sir. Not while we acquire from your sound card, because that feature is not available on the hardware sound card itself. While we acquire the audio signals from the MyDAC, you will definitely have that control, sir. Yeah.
Okay, sir.
Yeah. And acquiring from MyDAC is very similar to what we did in the last application, right? We went to DAC Assistant, from there picked up audio. I mean, we picked up AI 0. Instead, we just have to pick audio 0. And the process is absolutely same, right? Okay. So a good question. Thank you for asking that, sir. I'll move ahead now. So we have acquired the waveform. Now I'll answer a question which somebody asked one of us asked in the last section. What is this express? Why are we going into express again and again, right? So basically in Labview, there are 3 kinds of functions. Okay. One is express functions. One is low-level VIs. And the last one is the inherent nodes which are present inside Labview. Okay, these are the inherent nodes. These are the sub VIs, we can say, or low level VIs, and these are called express VIs. do you see any color differentiation between them? An Express VI always has this blue background. Whether I place a filter, or whether I place a acquired sound, both of them have blue background, sky blue background, right? So these blocks are called Express VIs because these are the ones which can be used to quickly acquire or quickly do a function through the GUI itself. I mean, in the GUI itself, I can put all these settings. Graphical user interface itself, I can put all these settings and do my job. So these are very easy to use, but also they have their own, I would say, disadvantages. The advantage is that the ease of use is the highest with an Express VI. I can simply double-click change settings. But the flexibility is something you lose on while you use Express VIs. So once you become slightly experienced in Labview, you will stop using these Express VIs and will shift to low-level VIs or the inherent nodes. These inherent nodes, which are yellow in color, cannot be opened further. They cannot be opened further. Even if I double-click, I cannot open it, right? If I double-click low-level VI, I will be able to open the front panel of that program. And I can further access the program written on the block diagram of it. Okay, so what are the three different kinds of VIs? Express VIs, low-level VIs, and inherent nodes. Yeah, is that clear?
In these, which ones we call as a low-level VI? The IOs are low-level VIs, we say, and others.
Not IOs. These are not low-level VIs. A low-level VI is something which can be opened and I can see a block diagram for it or a front panel for it, right? In the low-level VI, I will have to wire a lot of inputs. You can see various input nodes, input and output nodes. I'll have to wire a lot of things to make it work. Whereas on an Express VI, I have to do minimal wiring to do the same thing. Yeah. Just to give you guys an example, last section we did something called DAC MX. We acquired data from our MyDAC, right? So we used this DAC assistant. We acquired an analog input. Finish. I'll leave it to default for now. Okay. So we had used, let it build this block, but I can also do the same functionality using low-level VIs, but I'll have to use many more in number, and I'll have to connect them together. Okay. Now, if you can see these low-level VIs, right? I can change their maximum minimum value, which channel I need to acquire from in real time. Do I have that functionality here? Can I change that during the runtime? No, because I have to double click this. During the runtime, I cannot double click this and change value, right? Whereas in the case of low-level VIs, I have these controls at my hand. I can change them during the runtime also. Okay, so the functionality which I have made here using low-level VIs is same as functionality written under this program. Okay, written under this DAC assistant block. Okay, the only advantage, I get more flexibility.
Sir?
Yes, sir.
One more thing I want to ask. It's like a bit of out of context. It is from the second session we had in the day. So
Okay.
we used some spectral analysis block, right?
Right.
Over there. And there we were having a Fourier transform output of the frequency, like the signal. We were getting a frequency domain output for the given signal. and we
Okay.
used the graph to waveform graph to plot it. And
Okay.
sir, my question is why that waveform graph is named as amplitude and time? Like if I am plotting a Fourier transform signal, then it should by default take frequency and that amplitude still okay. Amplitude is okay, but it should take frequency at its independent scale. So it's not taking like that. So is it some error or some in the designing, or it's like overlooked?
No, it's not like that. So NI cannot, I mean, these data points are not picked from anywhere. User will have to set this, like it is showing amplitude right now. But what I'm getting is a normalized amplitude, not the actual voltage amplitude, right?
Yes.
So
Yes.
graph would not know what you're really wiring to it. You will have to define it to it, right? You will have to give it. The default value on the graph will always be amplitude and time. You will have to provide data to it saying, okay, on my x-axis, I am not really plotting time. I have wired frequency to it. That is the case for any programming language, right? In any programming language,
Yes.
if you plot something, you'll have to give the x-axis and the y-axis.
X-axis and y-axis labels we give.
Yes, even in Excel, when you plot a graph, you will have to do that. Right?
Okay.
So I would say time right now because this is a time signal.
Hello.
Hello.
Answer. Actually, I think in MATLAB, just like CRO and spectrum analyzer, do we have such facility here in this Labview?
Not really, sir. I mean, we don't call them spectrum analyzers and CROs. That is a simulation terminology, sir. While you do simulation, you use that terminology. In these simulation softwares from NI, you would have that terminology. So NI has something called as Multisim, which is the SPICE simulation software. On that simulation software, you will have the CRO and those features available, which you see in Simulink. Now there is another simulation
Vinit,
software. Yes, sir.
Elvis also. Elvis.
Okay. Okay.
Elvis board will have those functionality, na? Multimeter.
No, sir, I think what sir is asking, Ashok sir is asking is, there is a software feature inside Simulink where you can just drop a CRO feature. So what it basically does is it probes that wires and plots that data onto a graph or a waveform. But that's a very simulation-centric. That's a very simulation-centric terminology, sir. And that happens at two places in NI. One is in the SPICE simulation software while you do SPICE simulation, which is called Multisim. And the other one is control design and simulation. Control design and simulation will also have your CROs, etc. Right? Similar feature as Simulink.
No, that was not my point. I'm just asking because we need to change the axis. Though we are doing frequency, means spectrum analysis sort of thing using FFT, but we have to change the axis. That's what I'm asking. Is there any feature where automatically we are getting frequency axis instead of time?
I am not sure, sir. I'll have to check and come back.
Yes, that's what I'm asking.
Maybe
because
after
it's sometimes people who doesn't know what is frequency analysis or spectrum analysis or time domain analysis, and when they are doing frequency analysis, they will get confused.
Understood. True, sir. I think I can. Not sure how it can be done automatically, sir. At least I don't know to the best of my knowledge. I can find that out and maybe.
No problem, sir. We are teachers. We should learn every time. No problem.
Okay, understood, sir. So now, what I was explaining was that these are express VIs, right? And the low-level VIs were on the other screen, right? Now, why I brought up this discussion of express VI is because we learned about data types in our first class. Now, the data type out of which is coming out of our express VIs is called dynamic data type. Okay, this data type is called dynamic data type. Okay, now I really want to convert this dynamic data type into my waveform data type. Okay, now what is waveform data type? To really understand waveform data type, let us first understand arrays. Okay. On the first day, Parikshit sir had talked about arrays. What is an array? An array is, what is an array? It's similar data type. I mean, one data type and having multiple elements of the same data type in either 1 dimension, 2 dimensions, 3 dimensions, and so on and so forth. So how to create an array? I go on the front panel, right click, place silver, and go to array, place an array. Okay. Inside the array, now you can see this array is black in color. What does black color represent? What does black color represent? Black color represents that data type is not yet defined in Labview. To define a data type, I will go to the front panel, go to silver, add a numeric control to my array. Okay. Now I will add 1 here, 2 here, 3 here, 4 here, 5 here, and 6 here. Okay. So these are 6 elements, 1, 2, 3, 4, 5, 6. If I plot it onto a chart, okay, let's say I plot it onto a waveform graph, let's say, okay, and go to the block diagram. You need not do this. You can just look at the screen right now, what I'm trying to explain. So I will run this. What you would see is these points are plotted at 0, 1, 2, 3, 4, 5. I can change the plot type for us to able to visualize this better. Plot point style. You can see these points are plotted here. Can I by any means to an array give timing information? Array is just set of numbers. It is not giving me any sort of timing information. Am I right or wrong?
You're right, sir.
Yeah. What if I want to give timing information along with these numbers? Can I give it in an array? Can I give timing information in an array? We just discussed that array is of a similar data type. That means all the elements in the array should be of the same data type. So what do we use for elements which have different data types? In C, we use structures. I mean, it can have, a structure can have string data type also, array data type also, Boolean data type also, right? So what I'll do is I will create a structure in Labview now, right? Structure in Labview is known as cluster, right? So I go to the front panel, right click, go to silver, and I place a cluster. I go to array, matrix, and cluster, and I place a cluster, right? If I look at the data type, this is again black in color. Why? Because I have not defined the data type of this cluster, right? I will break this wire, bring the array inside this cluster. Okay. And I would say auto size to fit. I have this array inside this cluster now. You can see on the block diagram, this has become pink now, and the array is missing from the block diagram. Is everyone with me right now?
Sir, we were just listening. Means, do we need to do along with you? Means.
No. Don't do it. Don't do. But doing will need some practice. But just try to understand the concept. Are you able to understand what I'm trying to do right now? I'm trying to.
Yes, sir. The array is integrated with the cluster.
Inside the cluster, right?
Yes, sir.
Now I will add a numeric constant again, or a numeric control again inside the cluster. So one data type is an array data type, but the other data type is
Numeric.
numeric now. Can I add a Boolean also to this?
Yes.
I'll go and add a Boolean also to this. So what we have now is we have an array, we have a numeric, we have a Boolean together into the same data type, into a same element, right? So this is called cluster in Labview. This is known as structures in C. Now we have got an array, element array. Can I define my T naught here? Okay. Can I give T naught here? T naught would mean the time difference between two samples. Can I give it as 0.1 seconds? Yeah. By doing this, can I integrate the timing information into my data? Do you agree or not?
No, sir.
Okay. That means I'll explain it again, sir.
Yes, sir.
So I had this array separately outside first, right? This array had 5 elements, which is 1, 2, 3, 4, 5, 6, or rather 6 elements. 1, 2, 3, 4, 5, 6. That is agreed.
Yes, sir.
If I ask you to plot these 6 points on the graph, what will you do? You will just plot, the x-axis will not be time. You will just plot them against index.
Yes.
The 0th index 1,
1.
first index value 2, second index value 3, third index value 4, fourth index value 5, fifth index value 6.
6.
Right? But what I want to give is I want to give a timing information. I want to have time on the x-axis. Yeah. I want to have time. To add timing information, I need to give time between two samples, that between this sample and between this sample, how much was the time difference? If I'm able to tell that, then will I be able to define the x-axis in terms of time?
Yes.
Agreed?
Yes.
So an array can only have one type of data. So I need to use a cluster for this to give a timing information, right?
Yes.
Now, I just added Boolean as well to just show you that you can add multiple of these. But for creating a waveform, I just need the, it's not T naught, actually it's dt, the time between two samples, and the samples. But then also, I would not know at what time my waveform started, right? At what time my waveform started, that information will still be missing. So I'll give one
Boolean.
timestamp input, not a Boolean, sir. Boolean cannot tell us the time right now, right? It's 3:15 on 27th of September. That information Boolean cannot tell, right?
Computer
So,
time stamps.
yeah, we need to give a timestamp to it. Yeah. Now, if these three informations are available, that means my timestamp of the starting of the waveform, the dt sample between two samples, and my numbers, my each of these sample points, then I can sufficiently define a waveform, when it started, what frequency waveform it is, and what are the points, what are the samples, right? Now, do you agree?
Yes, sir.
Yeah. Now, instead of you building this from scratch, what Labview does is Labview gives you these three elements: the array of data points, the sample time between two samples, and the timestamp as a waveform data type. Okay, as a waveform data type. So I'll go back to the acquire sound signal. This was the dynamic data type. This blue wire was a dynamic data type which came out of my express VI. What I want to do is I want to play around with the frequency of the signal so that I can make a talking tom, right? So what I'll do is I will first of all convert this waveform, this dynamic data type, to a waveform data type. How do we do that? Let's see. Go to the block diagram, press Control space, and say convert from dynamic data. Okay. As soon as I place this on the screen, it gives me various options. Now, what I want an array of waveforms. Why an array? Why not a single waveform? Why I'm selecting an array of waveforms and not a single waveform? How many channels did I select in my acquire sound option, acquire sound block?
Channel 2.
Two, right? Since I have two channels, I will have two waveforms. One for one channel of the microphone, second for the second channel of the microphone. Agreed or not?
Yes, sir.
Yeah. So I will choose 1D array of waveform, and I know there will be two waveforms if I connect this dynamic data as the input to this. Yeah. To confirm whether you had two channels or not, you can simply come to your front panel where you had plotted your sound signal. Just expand this. There's plot 0 mentioned. Just expand this. Okay. And once you have expanded, let me know. Then I'll talk about the next step. Okay. Once you have expanded, you see plot 0 and plot 1. I'll go and click on the waveform, this line of the plot 0, and say plot visible, or rather uncheck from plot visible. So you can clearly see there is another waveform which is overlapping the first waveform, which is nothing but the second channel of my microphone. Okay.
Sir, kindly come again about that. How
Okay. Okay, no problem. Let's do that again. So you have this waveform on your front panel, sir. You have acquired the sound waveform.
No, sir.
Okay. You have this acquired sound block, sir, on your block diagram.
Yes, sir.
You have this set. Okay. Can you, on your front panel, can you create a waveform graph?
But that is the issue.
Okay. So let me do that again with you, sir. You have your front panel with you in front of you.
Yes, sir.
Right click on your front panel.
Yeah.
Go to silver.
Yeah.
Go to graph.
Yeah.
And go to waveform graph.
Yeah.
Okay, and place it on the screen. You can resize this to make it bigger.
Yeah. Yeah.
Sorry?
Yeah, sir, done. This was done already, but I suppose
Okay.
about that.
Okay, now what you have to do is the wire connected between the data output terminal of the acquire sound to the waveform graph?
Yes, sir.
Now acquire your sound. Let me acquire it along with you. Hello, my name is Vinit. I'm doing a workshop on Labview. So you can see the data got acquired. In your case, were you able to acquire?
Yeah, I'll just.
I'm sorry, Saurav sir, I missed your voice. Okay, just test it out and let me know whether you got this data. Now, what I'm claiming is this is two channels.
Yes, sir. Yes.
Got it? Great.
Yeah.
What I'm claiming is it is two channels, not one channel. Okay. And if you drag this, there is a plot 0 mentioned on top of your graph. Expand this. While you expand this, you will find there are two. Okay. You can actually expand it further also, but that does not mean our waveform has that many channels. You can expand it to, let's say, plot 4 or 5, but start making each one of them invisible. So let's say I make the first channel invisible by removing this plot visible property. So you can see there is a red waveform, which represents the second channel. I come to second channel and make this also invisible. Do I have any other waveform here? No. That means I only had two channels in my data. Okay.
Sir, can you please repeat, sir? Means if we extend that, we will get multiple. Means we don't know which are active or inactive. Yeah, this one.
Now, while you expand this, sir, all of them are available. Like all of them are active right now, but the data is only available in 2 of these. Okay, how do
Yeah.
we know? If I make them invisible, you will find nothing here. Nothing is given, no waveform is plotted here, right? So that means no data is available in plot 3 and 4. So I will remove these. These are empty graphs, empty locations.
Okay, means you just made invisible for plot 0 and 1, right, sir?
Yes, sir. So like I expand this, this is visible. You can see this is visible. This one is also visible. This one is also visible. But since they don't have data, nothing show up on the graph. I will make the blue one invisible, the red one invisible. But the green, the sea green and the third green, I don't know what is that color, they are not on the graph right now.
Yeah, means
Why?
there is no data, sir. Yeah, just
There's no data.
a way to cross check it, right, sir? Got it.
Yes,
Got the point.
just a way to cross check. Okay, so we have these 2 channels here. So what I was explaining is this is a dynamic data type. I want to convert this dynamic data type into a waveform which gives me all the sample points. That means each of these voltage points or each of these sound level points along with the time. And as we understood on the another window that to have time, we need 3 things. One is the data points, the sample between 2 data points, and the timestamp. And these 3 things I am claiming that are available as a part of waveform data type in Labview. I will show you now how to convert this data into this dynamic data into waveform data type. Okay, so come to
Sir,
your
do we need to create the waveform graph too?
No. I mean, I just did it for one of the participants. He did not have data on his graph, so
Yeah.
I was just helping him out. Yeah.
Yeah. Yes, sir. Yes, sir.
So now come to the block diagram. Press Control Space. Okay. This brings up the quick drop window and type convert from dynamic data. As soon as you do that, you basically find a pop-up box asking for as to what data type you want to convert into. Since we are convinced that there are 2 channels of waveform in the data, I am using 1D array of waveform. Okay, and I will connect it to this input terminal. Yeah. Now the input is the dynamic data type. The output is array of waveforms. Okay. Now what I'll do is I'll again convert it back to dynamic data type for the movement and play the sound. Okay.
Sir, actually, I think I missed this one, sir. Means I have opened this convert from dynamic data.
Okay.
Next, what is the next step, sir?
Choose 1D array of waveforms.
Okay.
And say okay.
Okay, sir.
So you have got your waveforms now in this. Yeah. One is I can start manipulating these waveforms, or I can simply, first of all, play these waveforms to see whether my loop is working. When I say loop, whether I'm able to acquire and then generate it back or not. Let's try that. So what I'll do is I'll keep it like this only. And I will again go to express on the block diagram, go to output and say play waveform. Okay. You can test this device. So I have 3 speakers at my end. One of is the headphone. One is the speakers on my laptop. And I have a secondary monitor connected, which is from Videocon. That also has an audio output. Okay. So I have 3 output devices. I will choose the speakers of my laptop to test this. If I click test, it will test it. It will have a sine tone signal played. You could hear that.
Yes, sir.
Yeah. So if I click test device, I can hear a sound being made. So I'll place this block, choose speaker, and say OK. Yeah. Now, without manipulating any data, I can simply play back my waveform first. I'm not using this right now because this I'll use to make talking tom. But what I'm doing right now is I'm acquiring and simply playing back just to check whether my microphones and speakers are working fine or not. Yeah. So I will run it. Now, don't make your program just look at the screen. I am for the couple of seconds. So I'm running this, and I would speak out something. Say, my name is Vinit. And I would speak out something. Say, my name is Vinit. You saw that the recorded waveform got played back.
Yes, sir.
Yeah. So you can try it out at your end. So directly connect the acquired sound output to the play waveform. Okay. This manipulation I'll teach in a couple of seconds, but just test this piece out. That acquire connected to waveform graph and acquire connected to play waveform. Once you have tested it, let me know. Then I'll talk about the next step. Okay. One of us says tested. Participants, I know it's a Sunday afternoon.
Hi.
Hello. Okay.
Sorry for that, sir. Actually, I was testing, sir. It is replicating my voice.
Understood, sir. No problem. You can test it while you keep yourself mute on WebEx.
Sorry,
That's fine.
sir. Actually,
But that's fine. No problem. That's fine. Okay, so we have this block. Now we know that we are able to acquire and play the waveform. If anyone is not able to do that yet, let me know. Otherwise, I'll move forward. Okay, I'll move forward. I take that as yes. Okay, now
Vinit,
yes, sir.
One thing you tell me while convert from dynamic data type, you have
Yes,
selected 1D waveform, right?
Yes, sir.
And 1D array of waveform. Why we have not taken that channel one?
Which one, sir?
That there are, you have said now we are acquiring from 2 channels.
Right, sir.
Can we would have chosen that 1D channel that suppose we are acquiring from 1 channel only?
If you are acquiring from 1 channel, sir, we have to use single waveform, not these scalars. Because when you choose scalars will not have timing information. Scalars is nothing but an array of numbers. Whereas what we need is more than array of numbers, more than array of sound level. We need timing information as well. And hence, we need to choose either 1D array of waveform or a single waveform. But we need a waveform because we are going to play around with the timing.
Yes.
Okay.
Yes.
Okay, so we'll choose 1D array of waveforms here. I'll just do this step again. I feel some of us might have missed it. I will quickly do this step again. So I will press Control Space on the block diagram. I'll go to block diagram, click on the screen, and then press Control Space and say convert from dynamic data and place this block onto the screen. As soon as I place it, it opens up, asks me for options, and I choose 1D array of waveforms, put it as input. Okay. Now I have 2 waveforms here. If you want to see, simply create an indicator to this. Okay.
Sir, I have a small request, sir.
Yes, sir.
Actually, we have enlarged the font size, but actually they are not looking standard. Means, can you just make them as they were earlier? Means, if it's okay. Means,
Okay.
they actually the fonts are bigger than the what we say icons or something. They are looking like that, sir. So
Yes, sir. Okay, I can change that, sir. Not a problem. Font dialog. Okay. Let me test that out if that works. Yeah, it works. Okay. I will place some of them again so that you are able to visualize this better.
means as we can read that acquire sound in just a single line here, but when I come to means the screen sharing, it is of 3 lines. So
I got your point, sir.
it's a kind of some sort of type of distraction types.
Understood, sir. No problem. I'm making it again to smaller font size so that you're not confused. Express output. Waveform. Okay. Now it looks better.
Yes, sir.
Okay. So what I did is I placed this block of convert from dynamic data type into 1D array of waveforms. I got the array of waveform. On the array of waveform, I'll show you how I did this. So I had this block. On the outside, on the output of this, I right-clicked and said create indicator. Okay, I got an array of waveform. If you go to the front panel, you will see the exact same thing which we learned on the other screen. That we will have samples, we'll have multiple sample, which is the array of sound pressure levels, sound levels, and there will be T0, which is the timestamp of starting of the waveform, and there will be sample time between each of the data points. Has everybody got that?
Yes, sir.
And in fact, this is not just one element of that kind, there is an array of that kind. Yeah. So let's simply try this. I will acquire sound, okay, for 5 seconds. So it's right now acquiring sound. Let us see once the graph is plotted. So you can see the graph data is plotted onto this array waveform. I have 2 channels. As soon as I make it the array index 2, I don't see anything. That means there are 2 elements in this array. 0 element for one channel, 1 element for the second channel. Is that clear to everyone?
Sir?
Yes. Yes, Raghav?
Sir, here, as we can see, sir, the arrays can have infinite length even though they don't have any data, right?
Arrays can have infinite length.
I mean, infinite element. I mean to say infinite element boxes. Like on 0 on 1 we have the 2 channel outputs,
Okay.
but we can still go to 2 and see that no data is there. So that means it is kind of an array list in Java, right?
Raghav, I'm sorry about the limited knowledge. I don't know Java. I am a core electronics student, but I can say one thing.
Sir, I'm also electronics student, but we have a course on Java in our curriculum, so that's why I know.
Okay.
I'm also an electronics student, sir.
Okay. I'm sorry about my limited knowledge, Raghav. I don't know Java, but what I can tell you is what this 0 represent is on this array window, which array element should be represented, should be shown, right? So if I make it 0, then the first element of the array will be shown, right? I can expand this actually. Sorry, not this way. I can expand it. Okay. Now I know there are 2 elements. Okay. If I make it 0, the 0th element will be shown in the first box. If I make it 1, then the first element, the zeroth index is invisible. The first index of the array is visible in the first box. If I make it 2, then the second index of the array will be shown on in the first box. Now, while I do this, I can see this grayed out means there is no data here. This graying out of data means there's no data. That means there's no memory allocated to these array elements because they don't exist in reality.
Hello,
Yeah.
sir. Sorry
Yes.
to interrupt, but when I'm doing array and when create indicator, then it's creating another array. And when I am joining, making a line between them, then it's showing cross over it. It's not acceptable.
Okay. Can you show me your screen, Sarah, if you don't mind?
Yeah,
I can.
yeah, sure. Just a second. Hello, is it visible?
Not yet, sir.
Now is it visible?
It's loading at my end. Yeah, I can see. Okay. Now, Sarah said this array is of, right now the data type of this array is not defined, right? So you can simply delete this array. It is black in color, right? Black color elements don't have any data type, right? So just delete this part. Simply select and delete, sir. Control B.
Yeah, done. Is it?
Remove the bad wire by pressing Control B. Right click on there is a convert from dynamic data type, right? No, not this way.
Yeah.
Just go near it. Yeah, right click this. Right click the terminal. Right click the terminal, not on the element. There's a terminal. Yeah. Create.
Create indicator.
Yes. Yeah. Now you can see the array of waveform is created. Okay. I'll take the screen back. Saurav sir, okay. Is it clear now to everyone how we're creating this array of waveform?
Yes, sir.
Okay, now I will move to manipulation of this array. Okay, how we will manipulate is, now this is an array of 2 elements. I will index this first. Index array and get the first element out of it. Okay. Indexed, got the first element. Index means getting an element at a particular index from the array. So I want to get an element from the 0th index of the array. Now I will press Control space and look for a function called get waveform attributes or get waveform components. And I wired this here. Everyone done till this point? Will have to be little
After
faster.
the indexing, what we have done?
So press Control space on your block diagram and say get waveform components. Okay, and then drag it down to 3 elements and then wire it.
Sir, actually, after the array of waveform, I did not get the next step, sir.
Okay, so after this, you know that this has 2 elements and I want to play around with each element. So right click on the screen, go to array and say index array.
Okay.
Okay. I basically want to index a particular element from the array. So I use index array function and I connect the array to it and choose the index which I want.
Just a minute, sir.
We'll have to be slightly faster.
Please continue, sir. Sorry, sir.
No problem. Okay, so we majority of us got to this step, and I press Control and drag to copy paste this much elements. Make the index as 1. Okay. So what we did is we got the 0th index, got waveform components, got first index, got waveform components. And now what I'll do is I will multiply dt. There is dt here. I will multiply dt by a numeric control. Everyone done till this point? Participants, please help me understand if you have been able to reach to this point. If no, then let me know. I can help you.
Yes, sir, done.
Done till this point? Great. Thanks for the feedback, ma'am. And now what I'll do is I'll search for another function called merge or rather build waveform. Okay. I'll use function called build waveform, expand it, choose the attributes accordingly. I will pass through y elements as it is. I will pass through T0 information as it is. I will pass dt multiplied by a constant to dt. And I will do the same for the other channel as well. You are getting my point as to why I'm doing this? Basically, I will now manipulate the time between two different samples to change how my voice looks on the speaker or how it is heard on the speaker. Okay, then I would say post it. We use build array feature to remake our array. Done till this point?
Excuse me, sir.
Yes, ma'am.
So the block before the build array, what is that? I didn't get that. From
This one,
where
ma'am.
you got that? Yes,
This
sir.
one, ma'am. So
Yes, sir.
what this block is doing is it is building a waveform. So you can search for a build waveform block. Okay.
Okay, thank you.
Expand it further to have all the attributes set.
Yes, sir. Thank you.
Thank you.
Sir, I can't connect my array index to get waveform component. It's
You're not able
showing
to.
broken wire.
Okay. So. Okay. You cannot connect. So you have this array till this point. It is fine, right?
Yes, sir.
Then you have index array placed.
Yes, sir. I have placed.
How many indexes you have passed on? You have passed on 0 to this.
Yes, sir. I have placed one index array index and I have put a constant as 0.
Constant is 0, right? And then the output does the output of the waveform or of this index array look something like this, color wise, or no?
No,
Is
sir.
it okay?
Doesn't look like.
Can you okay? Can you send me a picture on the WhatsApp on the group itself? Others, in the meantime, please try to make the exact same program as what I've made. This is the complete Talking Tom application. We will see it now.
Sir?
Yes, Raghav?
Sir, what data type is the play waveform box is taking in? Because I see a red dot over there.
Yes.
There is a mismatch of data type.
Yes, you're right. It should be dynamic data type. So we converted dynamic data to waveform data type, but while giving it back to an Express VI, we had to give a dynamic data type, but we haven't given. I am directly connecting it. That was my next point, that we can also remove this Gaussian dot. Yeah, I'll show you how. Let me just help the candidate. Okay. So it was Deepak sir, right? Deepak sir,
Yes, sir.
there is a block just before the array. This block, right? Double click this. That should be 1D array of waveform. You have placed 2.
Yes, sir, I got it. Thank you.
Got it?
Yes.
Okay. Let's test this out. I will have to make y as, let's say, if I make dt, if I multiply dt by 0.5, okay, then my dt will become half. That means the sample time between 2 data points will become half, and whatever I will speak will look like a talking Tom is talking. So let's try that out. I'm running my program. Hello, my name is Vinit. I'm conducting a Labview workshop. Could you hear that? Not okay. It's set to earphones. I'll make it to speakers. Hello, my name is Vinit. I'm conducting a Labview workshop. Hello, my name is Vinit. I'm conducting a Labview workshop. Now, were you able to hear that?
Yes.
Yeah. I can keep manipulating these dt samples or the multiplication factor for the dt to keep changing it. Yeah. What if I make it 2? Now, instead of reducing the time, I increase the time between 2 samples. Let's try that out. Say, hi, my name is Vinit. I am conducting a Labview workshop. Yeah, you could see that how we could.
Sir, we couldn't hear anything. Like some kind of noise was there and that's gone. We couldn't perceive anything like anything logical or anything sensible.
Okay, no problem. Try it at your end, Raghav, because what is happening is I'm running it on my speakers and then it is going from my headphone to your side. So there will be distortions, but try it at your end. Are you seeing the similar trouble at your end?
Sir, I'll try it right now. Sir,
Yeah.
what we are doing over here is like we are changing the time duration between two samples, right?
Yes, for throughout the waveform.
For throughout the waveform, we are changing the duration between 2 samples, and that duration is causing a change in frequency. As a result, we get to hear a different kind of voice.
Absolutely. And that is how a talking Tom works, right?
Oh.
So a talking Tom basically increases the frequency of your whatever signals it captures, it increases the frequency of that signal. So that is what I did here. Okay, let's see if you can hear it this time. Let me change the audio out to my television, which may have a better sound level. Okay. I'll run it again. Let's see if you can hear it this time. Hello, my name is Vinit. I'm conducting workshop on Labview. My name is Vinit. I'm conducting workshop on Labview. It went very fast. I could reduce this to 0.7 or so. Hi, my name is Vinit. I'm conducting a Labview workshop. Hi, my name is Vinit. I'm conducting a Labview workshop. Were you able to hear now or still no?
Yes, we could hear. We could hear you.
Yeah. Okay.
Yes, sir, we heard it. Sir.
Okay. You have it, you tried it at your end, it worked at your end or no? How many of you were able to make it work at your end?
Hello.
Hello.
Sir, these two create waveform boxes, they are, it is showing mirror image. No, the previous ones, The first, yeah, these two.
Okay.
boxes.
Okay.
These
When you
two,
say mirror image as in?
mirror image as in Y0, P0 and DT are showing on the left side and this waveform is showing on the right side.
Okay, so that means you have used a block called create waveform. These first blocks are get waveform components, and these blocks are build waveform.
Okay, these are get waveform.
Yeah, get waveform components.
Sir,
Yes, sir.
sir, in build waveform components, I can see two outputs of the waveform. So it is designed like that because so that we can take multiple outputs from the same block.
You are talking about this input?
Yes, sir. This output, actually, that's the output or input?
That's an input, Raghav. What happens is,
okay,
let's say my y is same, right? I am not changing anything on the y. My T0 is also same, right? So what I can do is I can reduce this. I can reduce this as well. Pass this waveform directly here.
Okay.
And only the dt of the waveform will be manipulated.
Okay.
I didn't want to use a shortcut because I wanted to get yeah.
So we need to know the basic inside inside what's going on. So
Right.
that's okay.
Yeah, and feel free to ask your question. I mean, I'm not discouraging questions. I'm just saying that why I did not use that. Yeah.
Okay, sir.
Okay. And should we move on, or participants are still trying it? I want everyone to be able to make it run so that we can move to our next section of the workshop. Okay, a quick show of hands. Please enter yes on the chat window if you are able to make it run. If not, say no so that I know how many of you have done it. Yeah.
In the get waveform component node, I am getting y, and below y it's written attributes. How do I get T0 and DT?
Click on the attribute. You will find these inputs.
Okay.
I'll just be back in 5 seconds. Please continue working on this till then. I'm back.
Sir.
Yes.
So if we try to remove that red dot by converting it back to dynamic data type, will there be any significant change in the voice that we hear?
Should not be, but I've not tested it. Let's try that out together. So I would search for to dynamic data type, convert to dynamic data. Actually, Labview would have also converted it into the dynamic data only while a coercion dot was there. Hello, my name is Vinit. I'm conducting a Labview workshop.
Hello, my name is Vinit. I'm conducting a Labview workshop.
No, I mean, I don't see you. At least I don't hear.
No significant change.
Yeah, because Labview would have smartly converted it to dynamic data type while converting it back. And we are doing it implicitly here. Like we are mentioning it as to what is to be done.
Sir, this last array attribute, what is this?
This one?
This one.
Okay, I'll name out each of these functions so that we don't have a problem. This is build array. Okay, and
there are various types.
Yeah, I will mention out name, convert to dynamic data. By the way, I in the meantime, I'll just share one story. I mean, I started using Labview in second year of my college without having any formal training, right? There was no formal training conducted. So it's very intuitive. Don't be worried about what all is there. Feel free to explore. It's very intuitive software for you to explore. Right? You'll make mistakes and you'll learn from these mistakes and will be able to make programs. By the time we had published our first IEEE paper, myself along with sir, Parikshit sir had published that, but I was one of the co-authors in that. By that time, I had no formal Labview training. So without even training, you can do a lot in Labview because it's very intuitive in nature. Okay. Once everyone is done, we'll move to the next topic, which is quickly writing this data to file, and then we'll move to machine vision. Okay. We have got around 45 more minutes. Any questions, anyone in the meantime, while others are doing it? Hello, yes, ma'am.
Hello.
Yes, ma'am, I can hear you.
Sir, can we continuously run this program by using while loop and taking timestamp?
You can do that, ma'am. I can simply put this inside a while loop. The only thing is experience will not be that great. User experience will not be that great because we're not using a professional DAC system right now. I can make it run, so we'll see how it looks like. So it's running right now. Let's see how it works.
So it's running right now. Let's see how.
Okay, so it's recording the second waveform now.
Okay, so it's recording the second waveform now.
Sir,
and now it is, yeah.
Sir, how can we remove the time lapse?
And now it is, yeah.
You cannot, ma'am, right? Because it's recording for 5 seconds.
You cannot.
You cannot, right? Because it's recording your waveform for 5 seconds. For first the 5 seconds, it will continue to record. And for the next 5 into whatever constant you write here, for that much time, it will continue to play. So each loop is running for around, each iteration is running for around 8.5 seconds right now. If you want to reduce this time duration, let's say you want to record it for, let's say, 2 seconds, that is okay. Right? So you can say, hi, this is Vinit.
Say, hi,
I'm talking. So it'll continue to talk. It'll continue to record and.
It'll continue to talk. It'll continue to record.
Got it.
I think now my application is working, sir.
Sorry.
I mean, it's feeling like as if we are using in the mobile phone.
Yeah, I mean, we will not be able to mix that professional application in this short span of time, but definitely you can build that level of application also. I have built it in past, that level application also. So what we do is we give a record button to user. For, let's say, if you press record button for how much ever time you are looking at, till the time button is pressed, it will keep recording. As soon as you leave the button, it will start playing it back. That is what we do on a MyDAC typically.
Okay, sir. But in that application, I think it was automated, sir. Means it listens for certain set of time and it repeats by itself.
Oh, okay. I have not used that for quite a lot of time now.
So just now it gave the same feeling. So I just said it, sir.
Sure. Thank you. Thank you for sharing that feedback. Okay. Others? Any other questions? Where have we
Sir, in the build array, I'm getting only one input.
In the build array, you are getting only
one input side means.
Okay.
You have to drag it down. You have to drag it down.
You are having it like this?
Yes, sir.
Just drag it down.
Yes, sir.
You can skip this block if even if you behind schedule, then you can skip this block. Or I can remove this right for the moment. You can simply wire the output of this to play waveform. I'm also removing the while loop.
Hello, sir.
Hello. Yes.
Sir, it's showing an error that the sound driver or card cannot accommodate the specified configuration. Check that the parameters entered are within supported range for the panel. But I have checked it and when I click on it and test device, it's working fine.
Yeah. You had what is the constant you have? What is the value you have used here, sir? In these two controls, is it 0? Okay, 0.5.
0.55.
Sorry.
0.55.
0.55. You have used here. It should work then. Can you increase it slightly? Can you make it 1? Let's make it 1 and see what happens. In case of 1, it should play the same waveform back. If others in the meantime.
Yeah, sir, it's working fine. Sir, but I wanted to know how can we increase the time in this graph?
Time in this graph.
Yeah, how can we manipulate that time?
I didn't get a question, sir. I'm sorry.
I mean, in your case, it's showing 2 seconds. In mine, it's showing 1 second.
So you just have to increase. You have to go to acquired sound and increase this duration to 5.
Oh,
yeah. Okay. I'm assuming all of us would have done by now. Could you respond by saying yes to the chat window so that we can move to the next step?
Sir, hello.
Yes. Yes, Raghav.
Sir, I'm asking. Sir, in the acquire sound block, I see like we have options for adding device and or other things. So as you said that in my DAC it will be like using a microphone and it will be much better. So
Right.
while using my DAC also we'll be using this acquire sound block, or my DAC will do it automatically over there?
No, for my DAC you will use DAC assistant block, which we used in the last exercise.
Yes. So that DAC assistant block is sufficient.
Yes, that DAC assistant is sufficient.
Now, sir, suppose I attach a microphone, like not a like a microphone to my laptop,
Okay.
and I want to add I want to give a device over here, add a device over here. So
any sound device which is detected as a microphone on your Windows will populate here.
Okay, so that will be shown as an option here.
Yes, that will populate as an option here because your sound card will detect that.
Sound card will detect that. Okay. And sir, as I can see in the block diagram, there is an option for connecting device also. Like there is a wire loop coming from there, and so we can connect external device. So Labview has any like audio device that we can connect, like a waveform graph, like how to explain?
You meant this device index? You meant this this device input?
Yes, sir. This device input.
This is just a number, Raghav, which we are saying, because let's say this right now microphone Realtek audio, which is on my laptop right now, is assigned a number 0, right?
Okay.
So during the runtime, let's say I run it first with the first device, and then I want to run it with the second device. I can just increase this device index.
Okay.
Okay. And I can, for playing waveform, I can, let's say right now I'm playing it on my Videocon television. As you can see, these 3 are detected by my sound card, but I want to play it on some other. So I can create a control for this device. And on this, I can give a different index. If I give 2, it will play on my headphones.
Oh.
Okay.
So
Now,
basically, this block will identify all the speakers and the microphones, and it will assign an index number to that, and we can give an external control and change it during runtime.
Absolutely.
With the control.
Absolutely.
Okay.
Now I'll answer your second question. Okay. So we are engineers here who are aspiring to hit the industry, or you're at the verge of hitting the industry to build your careers. Now, why are we learning about sound here? Right? Today, why are we learning about sound here? Is it really needed in the industry? So when we go to industry, we don't acquire sound using our computers' microphones because they don't have that level of sensitivity. In industry, let's say we have to do noise, vibration, and harshness analysis on your car. Let's say Maruti is building a new car. They want to launch it in the market. Before it really hits the road, they will have to get various sorts of certifications from certification agencies like ARAI, right, which is in Pune. Now, while Maruti gets its certifications, they will have to prove that the sound level of the car is not beyond a certain level. So they will not put a laptop microphone there. They will put a professional microphone there, which are typically available from a company called Grass, right? They will put that, and at the other end of it, there will be a data acquisition device, something of this sort. I'll just show you. This is the NI DAC device, which can capture sound, very effectively with a 24-bit ADC built on top of it. Can go up to 204 kilosamples, and will have total harmonic distortion. Total distortion of the board itself is 119 dB or beyond 119 dB, which is a very, very fine number. So they will typically put a microphone on top of it. I'll just show you the microphone as well, how the industrial microphones look like. No, these are not the industrial ones. Yeah, these are the industrial microphones. This, okay. They directly get connected over a BNC cable to another DAC device, which acquires, and then you do the exact same procedure as to what we did in Labview today. which one was our program? Yeah. So you'll do a very similar thing here. Also, Labview has a very detailed library for noise, vibration, and harshness analysis. Today, we are just manipulating the frequency. You might want to do order analysis, octave analysis. For ride comfort analysis, let's say Maruti wants to build a car which will hit the road. They want to ensure that the noise from outside environment doesn't come inside the cabin of the car, or is at least reduced by certain decibels before entering inside the car. So they do the NVH analysis for ride comfort analysis. For that, they place various microphones inside the car, drive it on a test track, and record the waveforms to find out how much is the sound pressure level, what frequencies we are hearing inside the car, right? Another example, let's say you are a motor manufacturer, which is building a wiper motor for the car, as well as building the window motors, which goes inside your automated power windows. Now, would you like that you have bought a new car, but while you pull your windows up and down, it makes a lot of noise? You would not like, right? So what motor manufacturers do is, before the motor is really shipped out to companies like Maruti, Hyundai, or various other car manufacturers, they go through NVH analysis. They put again microphones, get inside an anechoic chamber where there's no external sound coming in, and then they do the NVH analysis of that motor to find out the sound level coming out of the motor. So in industry, NVH is a very big domain, right? But Labview can handle it very easily by simply doing certain signal processing on top of signals captured. Yeah. Did I answer your question, Raghav? I know I took a longer
Yes, sir.
time.
Yes, sir.
Okay. I hope everyone has done this now, is able to build this now. Is there any? Yeah, Saurabh sir, yes?
Sir, I wanted to know if we can manipulate the volume of the sound. I mean, can we just use a multiply sign after this build array and have a loud sound such that we can do something like that?
You can in an ideal scenario, but right now I tested it. What is happening is, so we can go on mute. There's some background noise. So I tested it out, but I think looks like our sound card is again normalizing it into a certain ranges. I am not able to amplify. With my DAC, we used to actually make a complete audio equalizer. I'll just show you where sound, bass level, treble level, and amplitude level we used to manipulate. I'm not able to do that on my sound card. You can simply multiply and try at your end. That's a very valid question. But I'll give you the example of audio equalizer. On a MyDAC, definitely by simply multiplying, you will be able to do that. Okay. I've posted a link in the chat window, which is an audio equalizer built using my DAC device, which has an audio in and out. Yeah. Did I answer your question, Saurabh sir?
Yes, sir.
Yeah. So if you're using my DAC, then simply you can put a multiplication sign here to increase the volume. Okay. But right now we don't have my DAC, so we cannot try that out. Okay. All right. I hope everyone is with me till now. Let's move on to the next section quickly. Very quickly, we will understand how to log this data to a file. So you can just look at it. Don't do it at your end. It may take some time. So you right click on the block diagram, go to File IO, and click on Write to Measurement File. Again, we are using an Express VI. It will simply, I can choose that I want to write to an Excel data. I can choose the file name. Let's say on the desktop, I will say audio workshop, and right now it is 417. So I will say 417, and I would choose empty time column. I'll keep all of this default and say okay. Now, if I wire this data, this will directly go into the Excel file. This, okay, selected. Okay, I added a control here just to show. Okay, now if I run this, I will be able to store this data into an Excel file. We will see.
Now, if I run this, I will be able to store this data into an Excel file.
Okay, this is my Excel file. We'll see a couple of zeros at the beginning, and then towards the end, we'll start seeing your data waveform. Can you see this data waveforms? All of them are around 0, but 0 point something. You can also plot a graph here. Yeah. So the exact waveform which had shown up on the Labview front panel is being written to an Excel file. Okay, there's another way to write this to Excel. Once you have acquired this data, you can simply export it to Excel. Okay, but that's not an automatic way. The previous method was an automatic way. Any doubts on this? Should we move on to machine vision section?
So write to measurement file where you have taken it from.
So
file IO, then
write to measurement file.
But I couldn't find it. Write binary file. Sir, in modern only or in silver?
Raghav, it's a function. It has to be on the block diagram, not on the front panel.
Achha, okay. Okay, sir, I'm in the block diagram. File IO.
Write measurement file.
Write delimited spreadsheet. Achha, yes. Okay, got it, sir.
Got it? Similar way, you will have read file, read measurement
Yes,
file
sir.
option as well. Yeah. Okay.
Yes,
With on that note, I hope all of you could understand the signal processing application. Let's jump on to machine vision application. We have got another 40 minutes. I'll try to do justice to next 40 minutes. So how many of you have installed vision acquisition software and vision development module? Vision acquisition software, I had given it as an optional. So how many of you have installed? How many of you have not installed that? Could you please put that on the chat window? I forgot to give the link of the. I have just posted the link of the sound equalizer also. By mistake, I had sent it to someone in private message. Okay, so Saurav says I've installed both. Okay, for those who have installed both, they can follow me. For those who have not installed both, it's okay. Just view what we're doing right now. Video will be made available to you on the video. By looking at the video, you can try out. Okay, so what we will do is we'll quickly interface my computer's camera with Labview. So create a new VI, right click on the block diagram, go to Vision and Motion, go to Vision Express, go to Vision Acquisition. Okay, and Vision and Motion, Vision Express, Vision Acquisition, place this onto your block diagram. It's an Express VI. If you place it, it will open up a dialog box. It is opening up the dialog box. As soon as it opens up the dialog box, it shows me a camera which is connected to my laptop. If I click on the run button, I can test my camera. Okay. There are other two options, which is folder of images and AVI. So let's say if you have an AVI video, you can refer to that. Or if there's a folder of images, you can refer to that as well. Let's say there's a folder which has 20 images. You want to bring it inside Labview, you can simply give the folder path on the next screen. Okay. So right now we'll go with the camera and click next. Right now it asks me for various options. The first one is,
Sir,
yeah.
Sir, I cannot see the preview. Okay, play button. Okay.
Yeah, you can
Okay,
simply
sir, it's done.
click on this play button.
Play button.
Now I'll show you a folder of images also, how to do that. First, let's look at the camera, and the next attempt we will play a folder of images. Okay. In the first attempt, let's click on camera, click next. Now there are 4 methods in which I can acquire images from the camera. The first method is I just acquire one frame
Sir,
and
this
let it get.
particular window is not showing.
Which one, sir?
This one, sir. One. NI Vision Acquisition Express. The previous one was showing. Okay. Select acquisition type. Do we need to select that?
Acquisition time is going to. Okay, anyways, I think the problem is solved. That's great. So there are 4 methods in which you can acquire. One is just acquire a single frame and then process it, or continuously acquire and continuously process it, right? Or acquire finite number of frames and keep processing it one by one. So we acquire one, it gets processed, then acquire second gets processed, and that happens for n number of times. Or the last method is we acquire 100 frames or 20 frames or 30 frames in one go, and after they are acquired, they are processed one by one. Is all of you clear with these 4 methods? I typically use this one, which is continuous acquisition with inline processing. And I click next. It is asking me whether I want to log images. I don't want to log images. And it asks me for what controls and indicators I want on the screen. So I want the image number. I also want the frame rate. Others, I will leave it like that and say finish. It's creating a Labview VI. Okay. Okay, so I have this while loop. I will create some space in the while loop to run this. I will look at the frame. I'll create a frame rate indicator here. Okay. Now I'll run this. You will see images being acquired in real time. So it is right now not showing the full frame. It is showing a half of the frame. So I can right click this and say zoom to fit. Okay. So you have a full view on the screen, and I can stop it. So by just simply putting this block, we are able to acquire images from the camera. While you work in the industry, definitely you will not acquire images from the computer camera. You will use an industrial camera. How does an industrial camera look like? I'll just show you. An industrial camera is typically like this. Yeah, these are the standard cameras for a company called Bansal. It's a German company. They typically connect over USB 3, Ethernet, or camera link to a computer. Okay. So we acquired images. Let's see how we can process these images. I'll run you through a few examples of processing these images. Before that, I promised that I'll help you understand how to acquire from a folder of images. Let's do that. So I'm again opening the vision acquisition block. And I would go back to the acquisition source. I will choose folder of images at the acquisition source. I would say next, continuous acquisition with inline processing. And now it gives me an option to choose folder of images. Let's say I use this image, cycle through the images. You can also enter this path. This images will be installed on your system as well. Okay. It is building the program. Has built the program. Now you can see it is picking up images from that particular folder. Is that okay? Is it quite intuitive, difficult to understand? Guys? Hello? Am I
Hello.
audible? Yes, yes.
You are audible, Vinit.
Okay.
Yeah, someone said it is easy, sir.
Okay.
Sort
Okay. I hope it's easy for all of us to understand how easily it can be done. I'll not spend too much time on this because it's quite intuitive. So let's get into the processing piece, which is slightly tougher. So do one thing: simply go to your start menu and type Vision Assistant. Okay, I will have to disconnect my second monitor before I open this because it needs a minimum resolution. So I will disconnect my second monitor and then try to open Vision Assistant. Okay. Is everyone able to open Vision Assistant? I have reconnected back my second monitor. Okay, opening.
It's opening, sir. So,
yes.
So it's showing an error message.
What does the error message say?
So it's saying Vision Assistant requires a minimum display resolution of 1152 by 864.
What's
Check
your
your display properties.
Are you using two monitors by any chance?
No, I'm using a single monitor. I'm on a laptop, sir. So I'm using a monitor.
What's the display resolution of your laptop?
So I have to check it.
Yeah, just go to go to your front screen display settings. You will find the resolution, right?
Check.
I also got the similar error 2 minutes back because my second monitor, one of the monitors had a bad resolution.
I'm having a display resolution of 1366 and by 768.
It needed
and
862,
that's the maximum.
Right?
Yes.
It's the maximum. Oh God.
It's the maximum.
Okay,
so
and this one needs, unfortunately, no. But there are other ways to work on this. There are other ways, of course. Let me check what it asks as a minimum resolution. Are others also facing the same problem? It requires 1152 by 864.
So if we hide the taskbar, then it will work.
Oh, then
in
it will
my
work?
laptop also, I did the
Yes.
same. Now it's working.
Yes, in my laptop is also resolution is not.
Okay. Can you try what just ma'am mentioned, that you can hide your
Hide the
taskbar?
lab. Yes.
Did it work by hiding the taskbar?
Just a second.
Let me also try in that case. How do I hide the task?
So that is only I'm figuring out how to hide the taskbar.
Actually, the window is filled here. Ma'am, could you help us? Ma'am had given the
Sure.
suggestion. Yeah.
So I did it yesterday. I just searched the option to hide the taskbar.
Okay.
Automatically hide the taskbar in desktop. So the second option, go on the top.
Automatically hide the taskbar in the desktop mode. Yeah. Okay.
Yes.
Okay, okay.
Now let's try Vision Assistant opens now on my computer also directly.
Let's see.
Yes, it's opening. Thanks a lot, ma'am. You saved us a good time.
No, it's not working in my case.
Okay.
Still not working in my case.
Okay. So you see, I mean, your resolution is 1376 by 768, right?
Yes, sir. 1366 by 768.
After hiding the taskbar, it should actually become that much, 852. Are you sure your taskbar is hidden?
Yes, sir. I've turned on the hide taskbar in desktop mode, so it automatically gets hide while I'm trying to run it.
Okay, do one thing.
Oh, yes, sir. Yes, sir. Now it's running. Now it's running.
Okay. Okay, I believe then all of us will be able to do that.
This was a good hack.
Oh, yeah. Thank you, ma'am.
This is a good hack to use this.
Welcome, sir. Welcome.
Yeah, thank you. Okay, now once we are on this screen, let's choose Labview. Okay, is everyone till this point?
Yes, sir.
Okay. Now, first of all, we will acquire images in this software. So just go to acquire images. Okay, and click on simulate acquisition. You could actually interface this with any of the cameras if it was connected to a computer. But right now, what we will do is we'll see a simple application of geometric matching. Right. So go to simulate acquisition and go to a particular path. I'll tell you the path. So the path is C users, public documents, national instruments, vision, examples, images, and then go to geometric matching and say select folder. Everyone done till this point?
Yes, sir.
Others, please.
Feature, please.
Okay. So you are in this window at least, the acquire images window?
No, sir.
No. Okay, no problem. Is the software open?
Yes,
Vision Assistant. Does it look like this on your screen right now?
Yes, sir. Yes, sir.
Go to acquire images. At the top, there is an option to. Can you see this option, acquire images?
Yes, sir.
Yeah, go to acquire images. Under that, there's an option to acquire from various cameras. If a camera is connected to a system, you can acquire from that. Like the way we saw, we can interface our webcam. You can directly interface your webcam by using this option. But what we're doing now is we're simulating the acquisition so that we can run a program and do some pattern matching and geometric matching on the images. So click on simulate acquisition. Once you click on simulate acquisition, done till this point, ma'am? Under this, you can click on browse and go to a path is C users, public documents, national instruments, vision, samples, images, and geometric matching. I am posting this onto your chat window also. Okay, select this folder. Is that done? Once you are in this folder, you can click on this option. This option will help you bring all the frames from that particular folder to the Vision Assistant window. So click on this, it will acquire sequence of 11 frames. After clicking on this, I got this window and I would say next, finish. It is acquired, not yet. Oh, I had to click next to start the sequence acquisition and then click finish. So I can see each of these images. Done till this point. Okay, I'll close this now, go to process images. Okay, now let's say in an industrial application, these are certain sorts of warshells, I think. Let's say these warshells have to go to customer as a spare part. Okay, now on a production line, we want to evaluate that whether at least 4 numbers of these warshells are going to the packaging or not, right? So what we can do is we put the camera, we've grabbed the images of the conveyor belt, which had these parts which are going into a single packet, right? I want to count these elements, whether they are enough or not. Yeah. So let me take a good image where they're not overlapping, right? Yeah, this sounds like a good image. I will use this image to create a pattern for geometric matching. Okay. Okay, there seems to be some problem. Able to Okay, I had to go to browse image. Then after acquiring, I had to go to browse image. In the browse image, I can choose this image. Okay. Once I have chosen this image, I will create a pattern of this particular object and will run a geometric matching algorithm. Okay, let's do that. So we acquired images. In the browse panel, we chose this image where creating a pattern is easiest, and then we'll process these images. To process these images, I can simply go to the processing functions machine vision palette. In this, I will have an option for pattern matching. Okay, I've clicked pattern matching. It will allow me to create a pattern. Okay, I would say next, and again I would say next. I would say finish. Okay.
Sir, where did you find the pattern matching?
I'll do that again for you. So these are various processing functions in Vision Assistant. Okay. The first one is if I want to change the geometry of this image. Let's say I want to rotate this image. Okay. Okay. I want to rotate this image. You can see image rotating. Yeah. So first one is for geometry, masking of image, changing the brightness of the image. Okay, you can see the right image is very much bright. Right? So various processing options are available here. There's histogram as well. Histograms tells us what's the intensity of the pixels across this line, right? So some of the pixels are 0 and some of the pixels are late 250, 225 to 255. So I know this image is captured using an 8-bit camera. So the maximum value of any pixel can either be 255 or the minimum value can be 0. The black ones will be 0. Whatever is white in color would be close to 255. So we can see a small variation from 225 to 255 onwards. That means majority of pixels are either 0 or between 225 to 255 on this particular line, which I have drawn. Okay. On this one, majority pixels are around 255. Okay. This is the logarithmic scale. If I put it in logarithmic scale, then this is how the histogram looks like. Histogram is nothing but for a particular intensity, how many pixels are there in the region of interest. Yeah. So there are various other features here. Similar way, in the second one, we have color operations. Let's say I want to extract one particular color out of it. This is already a grayscale image, but when we take a colored image, we can extract a plane out of it. Yeah. So these are color operations on that image. Then these are filters, various sorts of filters to remove rise noise, to remove various sorts of noise from the image. These filters can be used. Okay. Then these are binary morphology. Let's say there are certain, after filtering, there are certain holes or certain places where we have lost data from the image that can be filled using basic morphology, basic morphological operations. Then this is basically the most useful tab. In this, you will find features like max clamp. What is max clamp? It tells you the maximum size of an object. So let's say I use max clamp, okay, and I draw my ROI here. So it found out the starting edge is this one and the ending edge is this one, and gave me the distance between them in pixels, right? I could rotate this also to find out the maximum distance between them. Yeah. So it is right now taking this edge and this edge. So this endpoint and this endpoint. Okay. If I make the ROI smaller, you can see starting edge is this one, the ending edge is this one. Yeah. So there are various vision inspection algorithms available here. I am using one of those, which is pattern match. So in the 5th tab, I choose pattern match. Okay. Clear, Raghav? You would ask this question where I found this.
Yes, sir. Yeah.
Okay. So I choose the function now. Let's say this is the function for the, so this is the area which I want to create a template. I'll click next. Okay. Again, I'll click next. I mean, here, what you can do is you can remove a certain piece of the template. Let's say I don't want to consider this as a part of my template. Then you can remove it. But I don't want to do that. I want to choose the complete area. Okay, I have removed this. Okay, now it will consider all of this complete image as a template. If I want to remove certain sections, you can simply draw with your pen and remove certain sections if you don't want to consider them as part of your template. I would say next and finish. It will ask me to save the template. So I'll name it as template, saving it on the desktop, a PNG file. Now it asks me to set the features of this algorithm or certain settings of this algorithm. So it is, first of all, it is asking me number of matches to find. I'll make it at least 5 or 6. Yeah. So it will help me find 6 of these matches. Right now it has only found 1 match. Let's look at other settings. Other settings is, can this component be rotated? If yes, in what range? So right now it is selected as -10 to +10, but my component can be anywhere between -180 to +180 degrees. Yeah. As soon as I do that, you can see the other 3 are also detected. Yes or no? With me, participants?
Yes.
Or you are tired
Yes,
for
sir.
today? Yeah. Now they can also be scaled in certain cases. Scaled as in one of them could be smaller, the other one could be bigger. It could be just the camera perspective angle also. So I'll also switch on scaling. Yeah. So for scaling, I would say somewhere between, let's say, 80% to 120%. Okay. They could also be overlapping with each other, as we saw in certain other samples. So we'll also increase the occlusion. They can be occluded up to 25%. Okay. Then I'll go to further options. I'll leave the algorithm to geometric match. Geometric match is basically pattern matching with size and orientation variance. Okay. So the way pattern match works is, pattern match takes a pattern and tries to correlate that pattern across the whole image. Wherever it finds the maximum correlation, it declares that it has found a pattern. Okay. Or if it finds a correlation score, greater than the score set by the user, then it declares a pattern is found. But a geometric match doesn't work that way. You can see we are using the geometric matching right now. So we have made it geometric match. In geometric matching, what happens is it creates contours. Can you see some green lines here around this object? Can you see these green lines? Yeah. It has basically detected contours, the outer edges of the template, and it is comparing the outer edges of the template than to the whole body of the pixel. I mean, not the whole body of the object, and is not correlating all the pixels. It is just correlating the edges. Okay. So geometric match makes it size and orientation variable. That means even if the size and the orientation differs for a particular object, it will still get detected. Okay. Now we can see the score of these three objects is somewhere in the range of 1000, 986, 982. I can, the minimum score for correlation is set to 800. If any object is matched with these contours, having a score of greater than 800 will get detected. So I'll reduce it a little because in certain other images, it may not get detected at 800. So it's good to have around 600 score. Okay. And I would say, okay. Yeah. Once I say okay, I can test it for other images by clicking on this run button. Okay, you can see it has found 4. Can you see it has found 4? Now, it has again found 4. And this one also it has
written.
Sorry? No, can you see 4 boundaries?
Yes, sir.
Yeah,
Red
so
color boundaries.
Yeah, red color boundaries. It is detecting those. If I double click this, I will be able to see the score of all 4. Yeah. Now I'll run it further. Now, even if they are occluded, that means one is overlapping the other, I am still able to detect them. Yeah. So what we will do next is we will now, we used a software to quickly prototype our algorithm. We will quickly export this program to Labview, okay, and use it there. How do we do that? Go to Tools, create Labview VI, okay, choose a path of the VI. So I would say desktop, geometric match, and I would say metal strips, and I would say, let's say it's around 450 now. So 450. I would say, okay. I'll say next. Now it is asking, how do you want to get the images in your program? Should I acquire images? Should I just give you a control where you can feed in images, or allow you to acquire images? So I'll say, let me acquire images. So I'll give image acquisition. Next, I will leave it to, I'll add the matches, calibrated matches, and number of matches as our indicators on Labview window. Okay. And this is helping me choose the controls and indicators I want on the screen. So I want these 3 indicators on the screen, and I would say finish. It will start building the program for me.
So, hello?
Yes. Yes, sir.
So, in the image source, we are using image acquisition or image file.
Image acquisition, sir.
Why not image file? Because we are using, these images are coming from a file, right?
If I choose image file, it will pick up only one file, which I have, which I'm using right now, which is on the screen right now. But what I want is, I want to cycle through the folders.
Okay.
Right? So choose image acquisition in that case. And once the program is built, in that we will make certain changes to cycle it through the folder.
Sir, in the controls and indicators, there has to be done anything.
In the indicator, choose all of them.
What? Matched, calibrated match number. Acha, okay. This will tell me, okay, understood.
Right. So you will basically find out, yeah.
in the control, these three options, what is the significance of these three options? ROI, descriptor, settings, and template file path.
So
Template
basically,
file path is like will give the image path of the image source.
We had created a template while making a pattern match algo, right? It is saved
Yes.
onto my desktop. This is the template we had created. I think this one or this one. We had created this template, right? Now, if you make that as a control, Labview will allow you to choose from the Labview window this template. Okay. I have not selected it because I didn't want to create further confusion. You can, if you select it,
Excuse me,
you
sir.
Yes, ma'am.
So in my case, in my laptop, there are two versions of Labview, Labview 15 and Labview 18. But in I have installed these drivers in Labview 18. But this Labview assistant is taken in default way Labview 15 after finishing this task in NI Vision Assistant.
Okay, so while creating a Labview VI, you will have an option here to choose between 18 and 16.
Okay, got it.
Okay. So, yeah, so I think Raghav, you had asked this question about the template file path. So right now, I have not chosen it as a control because I want it to remain as a constant. But if you want to give it from the user side, you can select that as well.
Okay.
Right? What Raghav is asking participants is while we create this Labview VI, let's say I take this and give image acquisition, then whether should we choose these or not? What's the significance of this, right? So template file path, whether you want to give or should I use constants? If you don't select this, it will use constants. If you settings will be the camera settings or the acquisition settings, that I'm asking choose constant. I don't want to give it from the user side. And ROI descriptor also choose constant. Okay, is what I have asked the program. Okay, I've cancelled it because I've already built the program. Is everyone with me till this point? All of you are able to make the program?
Sir, in my case, Labview 2050 should and NI Vision 2015 and
Sorry?
choose Labview 2018.
Right. So while you go ahead, you don't have an option to choose 2018?
Yes, sir.
Okay. That means while installing, probably you have not. Did you install by any chance Vision Toolkit before installing Labview 2018?
I have installed Labview 2000 NI Vision 2018 tool.
Then ideally you should have an option here, ma'am. But I can look at your system separately. I got it. There's some installation error. I can help you out separately to correct that, ma'am. Yeah.
Okay, sir.
For now, when you build it with 15, can you open it in 15 or it's not opening in 15?
So opening in 15 with some error.
With some error. Okay. For now, you can follow what we're doing right now. I will help you out separately, maybe after the workshop or maybe tomorrow when you are available to sort the error. Yeah. So right now, once you acquire it, a program is automatically built in Labview. Okay. So go to the block diagram, Control A and press Control U. First of all, let's clear the diagram a little. Okay. Done.
Still, it's a huge one.
It's a huge one because it's taking a lot of settings. If you remove those settings, it is just two VIs. Actually, just two VIs. There are a lot of settings and hence it looks bigger. This one is actually waste. This doesn't do much. It just finds the template path. Okay. Now I'll go to the vision acquisition block, double click that. Now I'll click back, choose folder of images as the source, then click next, continuous acquisition with inline processing. No, I will leave it to single acquisition with processing, the first one, and click next. Choose the same folder again, which I had given in the chat window. See users, public, documents, national instruments, vision, examples, images, geometric matching. Okay. Choose one of the images from here and folder of images.
Sir, here only any one image will choose or the entire folder?
Actually, it has to be the folder, but I have made it single acquisition here, so it's causing problem. What you can choose is you can choose continuous acquisition with inline processing. Okay, choose continuous acquisition with inline processing. Then it will give you an option to cycle through the folder of images. Okay, and then you can simply finish this. Okay, it is done. Now it will cycle through that folder, find out images. Okay. Now we have a hard task at our hand to put a while loop around whole of this program. And create a user control to stop it.
Sir, I'm facing up some problem, sir.
Yeah, what's the issue?
Sir, I've changed it to continuous acquisition and
Okay.
I'm navigating to geometric matching, right?
Okay. Okay.
And then I'm pressing OK, nothing is happening. It's asking for a file name.
Okay, let me see what you are facing problem with. Have you chosen a file here?
I've first we went back and then gone to folder of images, then continuous acquisition with inline processing.
Right.
Then as a cycle through folder images, I have to tick that. Then
You
only I can do that.
You have to tick that and choose a file. Choose any one file to start with.
Okay. Okay, sir. Understood.
And say finish. Is everyone with me? I know it's been a little long. We've had a long session. But I hope you are following me. Okay, once we have done that, we put the while loop around the whole program. Okay, we have a few more things to do. After putting the while loop, we'll first of all come to the front panel. Okay, take this image, let's align our front panel a little. It's right now very distributed. Okay.
Sir, we'll turn on the indicators, right?
What do you mean by turning on the indicators?
I mean, we'll tick the indicators like image number and frame rate indicators.
Where?
Sir, after choosing
Not
the file.
required. It's your choice. It's not required. It's your choice. Yeah, you can read it or you may not read it.
Okay, sir.
For this application, we don't need. Yeah.
Okay, sir.
Is everyone with me? If no, please feel free to put it on the chat window, guys.
Then after that, we'll put this setup inside a while loop.
Yes, we'll put the entire setup inside the while loop. Is that done? I can see a lot of participants have dropped by now. I think we have 17 now. Okay, I'll just take last 5 minutes and wind this up for today. Done? Shall we run it? Guys, you there? Am I audible?
Yes, sir, you are audible.
Okay. The energy level is quite down. What happened? Are you following this or no? Okay. Fine. Is it done or are you facing any challenges? Should I redo some steps? Where are we?
Sir, we have run this program once, right?
Yeah, just run this program. You would see that you will find number of matches here, matches location, at what angle they are. All the information will be available in these boxes, right? The bounding box is not showing up, which is something we'll program now. Okay.
Sir,
So
what
you can
box?
the box which basically shows where we have detected the template, the bounding box or the overlay of the bounding box.
Okay.
That is not showing up.
The boxes with red boundary that we got to see in Vision
program.
Assistant.
Yes, Vision Assistant.
Vision Assistant.
Yeah. So that you cannot see here. What do we do to add those here is something I'll teach, but have you been able to do till this point? You are getting these matches, 3 matches for this, means let's say. Okay, I assume that as a yes. I go back to my block diagram. Now, here is where I present my image, right? I present my image here, right? Now, what I'll do is I'll press Control Spacebar, search for overlay multiple lines. Okay. And I'll bring my image here, remove this wire, pass this image through this overlay block and give it to image out. It requires the list of lines which have to be overlaid. So this matches, if you look at, these matches have a bounding box information, right? This match cluster, this is again a cluster. This match cluster has this bounding box information. Okay, I need to pass this bounding box to overlay lines block. So what I'll do is I will say unbundle by name, and this is an array, right? So I'll put a for loop here to process all the bounding boxes, pass one by one. So I'm not giving end terminal to for loop. Do you know why? Can anybody
guess?
Number
of matches will vary.
Because the number of matches will vary, and I have given it as an indexed tunnel. That means, let's say X matches are found, this loop will run X times, okay, and will create X boxes on the image out to show the red colored bounding box, right?
So now, how did you get a bounding box like control plus space and search?
Control plus search unbundle by name. To get certain components of a cluster, we use unbundle by name feature. Once you put unbundle by name, you connect it to the matches. It will show you various options, out of which I have chosen bounding box. Now add certain delay here for you to quickly see it. Otherwise, you will miss those bounding box being displayed. So add a 500 millisecond delay here. Okay. Is it happening for all of you?
Sir, I'm getting unbundled by name. Then after that,
So after unbundled by name,
like,
wire this matches to this unbundled by name.
sir, it's showing a bad wire.
You have passed through the for loop as an index terminal.
No, I've not put the for loop yet.
Yeah, you have to put a for loop because it's an array. So
okay.
It's an array of clusters. What we need is information from the cluster. So first of all, array has to be indexed. To do the indexing of the array, we have put a for loop.
Bounding box, okay. Got it, sir.
Got it?
Yes,
Great,
sir.
then we can run the application.
Sir, but until and unless we stop the while loop, we don't get to see the boxes.
No, we will.
No,
it is
sir.
inside the while loop, right? It is inside the while loop, or you have placed it outside the while loop?
Sir, it's inside the while loop. So it's because of the speed. You have added a delay also.
Yes, it's because of the speed. Because what happens is this happens at a very, very fast speed. And before you are able to see the results on this image window, a next image is acquired, which does not have those results. Right?
Okay. So a delay will help me see it properly.
Yes, a delay will help you see it. So you can see.
Stand. 1000. Okay. Now let's see.
Yeah. Okay, that brings me to the end of my session for today. Really, really sorry for extending it by around 60 to 60 minutes or around 35 minutes, in fact. I have posted a feedback form on the chat window. Please pass on the feedback for mine and Raghu's session in this workshop. We wish to learn more from each of the interaction we have with students and researchers. We wish to improve ourselves with every interaction we have with you. So I have passed on a feedback form. Please do mention your feedback. It's a very small form. It will take you only 2 to 3 minutes to fill out. Just pass on your feedback. It will be very helpful for me. Thank you.
So,
you have been a wonderful audience. Yeah.
So it's better if you just post this feedback form in the WhatsApp group, because now the meeting will be over and we will lose that. And honestly speaking, sir, right now I won't be filling up this form. I'll take a half an hour break and then I'll do something.
Okay, understood. That's a valid feedback. I will put it on the chat window on WhatsApp. Yeah.
Yes, sir. Yes.
Okay. Thank you. Thank you all. You've
Thank
been a
you, sir.
wonderful audience. Really appreciate you sitting through this heavy session. I hope you learned something out of this workshop, at
Yes.
least from my sessions. Yeah. Thank you. Have a good evening. Bye-bye.
Hello.
Yes, sir.
Thank you, Vinit. Thank you for
Thank you,
this.
sir.
I think it's quite longest session. I think
Yes, sir.
2.5, 3 hours maybe. Thank you. I think you have taught them so many things. Till we conduct next workshop, they can practice this.
Yes. And I had few interactions with participants. I think Kalpana ma'am, you had some problem with motor or drive as well as with your Labview vision thing. Please feel free to ping me on WhatsApp. I would help you out, whatever issues you were facing with.
Okay, sir.
Sure.
Nice. I
Thanks.
want to thank
Okay.
participants also. On this Sunday afternoon, they have taken so much time, and now you can have your teas. That will be very fine. Okay, thank you. We'll meet again tomorrow. With tomorrow we have lined up Dr. Nikhil Mariwala from Kurukshetra University. He will be giving you details about fuzzy controller, fuzzy system design, and in the evening you will have that system health monitoring, okay, condition monitoring of the systems. I think by Dr. Naresh Raghuvanshi. There is a slight change that tomorrow evening session is being taken by Dr. Naresh Raghuvanshi instead of Dr. Amit Singh. Thank you. Then I'll say bye to you, all of you, for time being.
Bye-bye. Have a
So
good evening.
yes, good evening. Let us meet tomorrow. Let us meet tomorrow at 9:30 a.m.